Hi friends. So today I'm going to give you a presentation for the taking of notes about lamps, okay? And this will be covered on our last and final quiz, so you should take the notes. I'm also going to just embed a couple of Edpuzzle questions in this video for you, so it's easy for us to know what stuff you've caught along the way. So lamps, here we go. So when we talk about lamps, every theatrical lamp is identified by an ANSI code number, okay, like HPL or FLK. That number doesn't have any particular abbreviation for anything. It's just a code, like a three-letter code, that is representing all of this data about the lamp, okay? So it's the shape, the base, type, the filament type, power consumption, lifespan, efficiency, all of that kind of stuff is embedded in that code information. Here are a few kinds of lamps. So tubular is this long and tall lamp. Then you have arbitrary, which is the kind that's in your lamp at home. So that's the only one I can demonstrate for you right now because I'm in a house, not a theater. PS is pear-shaped. B is a decorative lamp, like a candelabra fixture. So any sort of light bulb that is shaped like a flickering flame. Okay. G is globe, so a globe-shaped lamp. R is a lamp with a reflector in it. And a par has the reflector and the lens, and that's the kind of lamp that you would find in a par can. So parabolic aluminized reflector is a par. Here's a whole bunch of other lamp sizes and shapes. So this is kind of the broad spectrum of potential shapes. Here are base types. So we talked about this a little bit when we were taking the lights apart and putting them back together, which thank goodness we did before they shut down school. Screw bases are the ones that you find in your house. The sizes that we usually deal with, okay, so the ones that you should have some awareness of, are the medium E26, E27 screw bases. Those are the ones that you'll find in your house. Mogul are kind of bigger, more giant bases. And then candelabra and mini candelabra, so E11, E12, those are going to be on some house fixtures, like a lamp from IKEA might have a candelabra base lamp. They'll also be in chandeliers. So those are the three main sizes. Those little candelabra bases, those little candelabra bases can also be found on some theatrical lighting fixture lamps. So here's a bayonet, which have little knobby things, little nubbins on the bottom of them. Bipin bases, so a bipin base is like the lamps that the Source 4 minis had. Fluorescent tubes also have bipin bases, so that's any lamp base that has two pins sticking out. Another lamp we talk about a lot that has a bipin base is our HPL, which is our standard Source 4 lamp. So the ones for the Source 4s where you just pulled them in and pushed them out. Those are also bipin base lamps. We also have medium pre-focus, okay, and this is the kind that we had in the Fresnel until Dylan broke it, okay? So that pre-focus base has those two flanges, one is larger than the other, and that's the way you should put it into the socket, like in the Fresnel. That's the one I took apart completely during class. So that's your medium pre-focus base. Filament types, we're not going to worry too much about filament types as far as you are concerned. There are some specialty filament types. A lot of these are no longer dramatically used, right? So a lot of these are the kinds of filaments that you might find in a decorative light bulb that's meant for like a decorator situation to like be hanging in a hip restaurant, but not so much for theatrical use. And the reason is most of these, so like all of these ones and these ones on the other side, those are all too big, like they're too spread out to be valuable to us for a lighting instrument because a lot of the physics of that reflector relies on that filament being as close to a point source as possible. So you want as much light in as concentrated a spot as you can get it. So that's why most of the lamps that we have are these coiled, either coiled or coiled lamps, because those are tightly twisted, okay? And that makes brighter and also taking up less space. And we'll see that in this page, right? These are 3 lamps that we might find in the wild in our theater. So a BTL is 500 watts, an HPL, that's what we use for a source 4. That one is going to be 575 in the middle, or 375 if you want it to be less bright, or 750 if you want it to be more bright. And those 750 watt lamps have that 3rd pin to make sure you don't put it in upside down. And then EVR is an example of a theatrical lamp that does have a screw base, okay? So these 3 lamps have the 3 kinds of bases that we talked about, right? So there's a bipin base for the HPL, there's a screw base on the EVR, and the BTL is a medium prefocus base for Fresnel. Here are 4 types of lamps that I want you to have awareness of, okay? So we'll talk about them, and then Rick, the light bulb collector, will tell you about his, and we will take some notes about each one, okay? So your carbon arc lamp is one of the first types of electric light. It consists of 2 carbon arc rods that are touched together. They create that electrical arc, so it's like controlled lightning. And we use them in theater for follow spots. They used to be used for a lot more, but right now we use them for follow spots in theater. So let's see what Rick can tell us.
Okay, here we have my carbon arc lamp that's in rough shape that I'm slowly restoring in bits. This is a Thompson, and these lamps were used before incandescent lighting came around, so they were one of the first electric light sources. And all they are, this is a really big one, but they were just two carbon rods that touch together. And when you put current to them, a magnet would separate them, and it would form an arc between them, just like an arc in a mercury vapor or metal halide lamp. In fact, the light they put out is very similar to an MH or a mercury vapor lamp, and it's a very bright purplish white light. And they were used mainly for street lighting and industrial, indoor lighting, things like that. And they were made even when electric incandescent light came around. They still used them because incandescent bulbs couldn't put out enough light. And same thing today, where street lighting uses high pressure sodium, which puts out a lot more light than incandescent, and it's an arc light source. The arc lights were the high pressure sodiums of the late 1800s. They produce a lot of light, which an incandescent couldn't do, and they use relatively little power to do it. So the arc lamp was king up until, probably the 20s, actually. In England, they used them all the way up into the 1960s, even into the 70s. So arc lamps were with us for quite a while, actually, even though it was the first light source. These are some of the internal parts. This is the frame that goes down under here. And this is where your arc actually goes, your carbon rods. These are some of the windings from the coils inside that are actually shot. I'm going to have to redo them. And this is the ballast, which piece of insulation material here. And this is the ballast, or the choke coil. And the wires are right down to bare copper, so it's going to have to all be rewound. But basically, it's an HID light source, high intensity discharge. It's just, it does the arc in air instead of through a gas or a metallic vapor.
Okay, so that was the arc lamp. First type of electric light, 2 carbon rods, create controlled lightning in an electrical arc. It was used originally for industrial settings and street lights, and now it's used in follow spots. Next, oh my goodness, incandescents. Okay, so incandescent lights are our standard, regular, in your house light bulb, okay? So incandescent just means that you heat up a wire so much that it glows and gives off light, okay? So an incandescent light source is any light source that is created by pushing electricity through a thin wire, causing it to heat up enough that it glows. So what we use is a fine tungsten wire. So tungsten is a type of, it's like carbon. It's a metal. And we put it inside of the globe of the lamp. And then we fill that with either a vacuum, so either no air at all, or we put an inert gas inside of that. And when we do that, that prevents the filament from burning up, okay? Because if that filament is exposed to air, it will burn, okay? The electricity will go through that tiny wire, that filament. It will create heat and light, and because of that amount of heat that is required when it creates light, it would burn up if it were outside of the bulb. Let's watch what Rick has to say about the incandescent light.
Here's an incandescent bulb. You know, they've been with us over 100 years. We started out with first carbon filament lamps, and then around 1910, tungsten filament lamps. And we're still with tungsten filament lamps. And they have several advantages, several disadvantages. The advantages are that they're inexpensive, for one, and for two, they give a nice color rendering. Objects lighted by them look good. So they're excellent for restaurants, houses, things like that. They don't need any auxiliary gear, which means you can plug them straight into household current and run them. You don't need a ballast, so there's no losses from a ballast. And they have a decent life. Some of them are longer life than others, but most are about 1,000 hours. The disadvantages are they're not the most efficient light source there is. In fact, only about maybe 10% of the energy makes light, and the rest makes heat. How it works, it's a very simple principle. Incandescence, all it is you have a material, whether it be carbon or tungsten, tungsten's a metal, that you place inside of a glass bulb and you seal them either in a vacuum, or you make a vacuum, then you fill the space with a gas like argon or a mixture of argon and nitrogen, and you pass current through this material, which is really a fine wire, and it heats up. It's a resistor. In other words, the current can't pass through it easily. So when the current tries to pass through the wire, it forces its way through and it heats up the wire trying to do it. And in that case, it creates photons, which is light, and also it gives off radiant heat energy as well, which is actually another form of light, infrared energy. The reason why the filament is sealed in a bulb is because if it were exposed to the air, it would burn up in a few seconds because it runs at such high temperatures. So by putting a vacuum in the bulb like the old Mazda lamp has, it keeps the filament away from the air so it doesn't burn out. But with today's light bulbs, you fill the bulb with gas, and the gas exerts a pressure on the filament when it's in operation and makes it last longer, and it can run at a higher temperature and thus produce more light more efficiently without shortening the life of the bulb. So that's the object of putting a gas inside the bulb. Plus, it reduces blackening of the glass because the blackening goes to the highest part of the bulb. If it's base up, it'll be here. If it's horizontal, it'll be here. And if it's base down, it'll be here. So that the whole bulb doesn't blacken like a vacuum bulb does, and the bulb will maintain better light output throughout life, which is another advantage of gas filling.
So halogen lamps, these are our primary type of lamp we use in the theater, okay? So you can see that's a 750 watt halogen HPL fixture lamp right there for a source 4. It is a tungsten filament, so it's the same filament as a regular incandescent lamp. It is a type of incandescent lamp because it is an incandescent lamp with a halogen gas inside of the globe of the light bulb, right? And it also uses a quartz glass. So instead of regular glass, it uses quartz glass. This is the kind that you don't want to touch or it'll make the light bulb explode, as we discussed in class, okay? And what happens when you touch it is called devitrification. Okay, so that's what happens when the oil from your skin reacts with the quartz as the halogen lamp heats up. Okay, it's not going to happen if you touch it and it sits on the table, but if you put it into service and you put electricity through it and it heats up, then you are going to get that bubbling and discoloration, possibly an explosion. Not a good time. I mean, depends on who you are, but not a good time. Let's watch Rick tell us about his collection of halogen lamps.
What we have here is a halogen lamp, properly known as tungsten halogen or quartz halogen lamp. And this lamp is actually an incandescent source, which a lot of people may or may not be aware of. It works on the same principle as an ordinary incandescent bulb. Current passing through a high resistance filament heats it to a high degree of incandescence, and it produces bright white light. The difference with halogen is, number one, the outer envelope is made out of quartz instead of glass, and it's much smaller for the same wattage, and that's one reason for quartz to withstand the higher heat, because of the smaller bulb. Secondly, the bulb is filled with a halogen gas, which is unique in that it causes what's known as the halogen regenerative cycle. When the filament operates, tungsten atoms will evaporate off of the filament and deposit on the inside of the bulb, and it'll cause the bulb to blacken over time, which is familiar with ordinary incandescents. Halogens don't usually blacken much, if at all, because when the atoms come off of the filament, they unite chemically with the halogen, and when the halogen cools, the chemical compound changes yet again and actually redeposits the tungsten atoms right back on the filament again. And that prevents the filament from thinning down quickly and evaporating, so you can run it at a higher temperature and produce more light and greater efficiency with no loss of lamp life. As a matter of fact, you can increase the efficiency over an incandescent quite a bit and actually get longer lamp life from a halogen, which is a great advantage to it. The only main disadvantage of this lamp is that they run so extremely hot, and they're better off to be put in an outer envelope like these types are for household use. And also, you can't touch the bulbs with your fingers, because quartz, if your skin oil gets on the quartz and it gets hot, it goes through what's known as devitrification, which is what happened to this lamp. You see the quartz is all discolored and messed up. The filament is actually still intact, but the reason why this bulb looks like it does is because somebody touched it with their bare hands and then put it in use. And the heat of the lamp actually damaged the quartz. If this lamp were to be put in service, it wouldn't last very long, and it might even explode. So when you install a quartz lamp that has no outer bulb, no outer envelope, always hold it with a piece of tissue, or like I'm doing, hold it by the base so you don't touch the quartz. If you do touch the quartz, use rubbing alcohol and tissue paper to clean it off before you put it in service, and you won't have a problem. These are known as double-ended halogen lamps because the current is fed in from both ends of the lamp, almost like a fluorescent tube. And of course, there's single-ended format lamps as well, which, again, the automotive lamp, the headlight bulb, is a single-ended halogen type bulb. And this one's for an overhead projector, single-ended type. And there's smaller versions of these that you find in under cabinet lighting in kitchens, 12-volt ones and line voltage ones for a variety of applications. Other single-ended lamps are the ones that have an outer envelope, like this small floodlight bulb that screws directly into a socket. And these are for track lighting and accent lighting in the home and in business. You've got your single-ended bulbs for general lighting, and these are coming out in different types now. This is an older version, but they're still popular today. And a BT15 outer envelope fits a standard socket. And these are actually a great alternative to compact fluorescent bulbs. They're still considered energy efficient. yet they don't have the quirks that CFL bulbs do, and they have the same color quality as a standard incandescent. Plus, they're dimmable, which most CFLs aren't. For chandelier lighting, now they have halogen bulbs, which are a little more energy efficient. Okay, what we have here is a 500 watt T3 halogen bulb. It's probably the most familiar type of halogen bulb aside of the automotive type ones. And this particular format is actually the original format of halogen bulb, which came out back around 1962. Here's a pretty nifty halogen lamp. It's made by Iwasaki Electric Company in Japan. And what this is, it's what they call a double envelope halogen lamp. This bulb was probably used for general lighting, maybe in factories, you know, high bay fixtures or...
Let's skip into a slide. So this is the tungsten halogen cycle, okay? So these are the steps that the lamp will go through as it is used, okay? This is the thing that will be in the quiz, probably putting these steps in order, all right? So the first thing that happens is the electricity is turned on and the filament heats up. Then tungsten from that filament evaporates. It'll combine with your halogen gas into a tungsten halide, and then as the lamp is cooling down, that tungsten will be deposited back on the filament, causing the filament to last longer and also preventing the blackening of the bulb over time. So that's the tungsten halogen cycle, which is happening inside of all of our theatrical lights. It's part of why they're so much more energy efficient and why they can last for a lot longer than a regular household light bulb would. Our last type of light is the fluorescent. Let's do it, okay? So a fluorescent lamp, light bulb, right, whatever, is a small arc is created through a mercury gas, okay? So it's like a little tiny lightning rod, not like the big lightning that's out in the air that we have with the carbon arc, but just a little tiny trickle of electricity flows through the gas. That arc in the gas will give off UV light. So if we think about UV light, we're talking about the part of the light spectrum that gives you a sunburn. It's not part of the visible light spectrum though, okay? So when you take that UV light and they hit a phosphorus coating, which is the white part on the inside of a fluorescent tube, then that turns that into visible light, okay? This is the same idea as black light. So if it lost me. It was too excited. So same idea as black light. UV light is black light, basically. So it doesn't make anything glow unless it has that phosphorus in it. That's why if you're like at a rave, I mean, you're not at a rave, if you're at like laser tag and you have black light everywhere and your white t-shirt and your teeth and those other white objects glow, it's because they have that phosphorus content that's reacting with the UV light from the black lights, okay? So we'll watch Rick, who loves fluorescent lights, tell us about his fluorescent light collection.
Okay, here we have yet another light source, which happens to be probably my favorite light source as a bulb collector, fluorescent lighting. Today, fluorescent lighting is actually far more common than the good old incandescent. The basic principle of operation in a fluorescent lamp is simple. You have a glass tube, and inside, all you have in the tube at each end are electrodes called cathodes. And in the case of the hot cathode, they're like a little filament. That's why you have 2 pins on each end, because each pin goes to one end of the filament. And these filaments inside are electrodes that send current through the gas in the lamp. The gas in the lamp is argon, and there's a little bit of mercury in the tube, just a tiny amount, like just a pinhead amount of mercury. And how it works is when the current is switched on, These cathodes heat up and they're coated with a special material that gives off electrons. It works on the same principle as a vacuum tube, and it's called thermionic emission. When it heats up, it gives off electrons. And that's good because when the filaments heat up, they give off the electrons. Then a high voltage pulse is sent through the lamp from the starter, and that pushes those electrons through the lamp from one end to the other, and it starts an arc through the lamp, through the gas that's in the lamp, which is argon. And this argon arc makes enough heat to vaporize the mercury that's in the tube, and that goes into the arc stream and produces ultraviolet radiation, ultraviolet light. And the ultraviolet light hits a powder on the inside of the tube. That's why they're white. It's called a phosphor. And it's a material that glows when ultraviolet radiation strikes it. So when the UV radiation produced by the arc through the gas in the lamp hits the phosphor, it makes it glow, and that's what produces light. Now what I'm going to do, I'm going to start up a nice CSArts fluorescent lamp that was made by Westinghouse and branded as CSArts. They're actually not common today. That starts in a preheat fixture with a starter, and you'll be able to see the preheating of the lamp when I start it. Okay, here we go. Beautiful start. You see it blinked a couple of times because the lamp didn't catch on the first try, so the starter just reglowed, reheated, closed the contacts, and tried again. And the starter will keep trying until it restarts the lamp. There's a little delay. There's the cathode heat. There's the start. Beautiful start. The starter's really good in this fixture. This is a design that came out in 1939, and it's still with us today, and it's unbeaten in reliability. The reason why they have different colors, warm white, cool white, even solid colors like pink and blue and green, the reason why they create different colors is just because there's different blends of the chemicals used in the phosphors. Like, for example, if you took the phosphor for the blue lamp and mixed it in a certain proportion with the phosphor from a pink lamp, you could get a white lamp. And in fact, this cool white lamp I have in my hand has a specific blend of the blue phosphors and the pink phosphors, and it emits a white light by blending them in a certain balance. So the blue and the reds balance together and produce a white light. Of course, there's other colors emitted too, but blue and red are the predominant colors. And the simplicity of the lamp is its advantage. Another advantage is it doesn't get hot. The ends get a little hot to the touch because of the filaments, but not hot enough to burn you. The center only runs lukewarm because the current flowing through the gas produces mostly ultraviolet light, and it's at low pressure, so it doesn't produce a lot of heat, which is an advantage because fluorescent lamps can produce a lot of light on very little energy. And for general lighting inside of buildings, for white light, fluorescence cannot be beat in efficiency. And it doesn't matter whether you have an old fixture from the 1940s that uses starters and has ancient electrical gear inside of it, or the most modern electronic ballasts. The efficiency of the lamps hasn't changed much over the years. The disadvantages are few. Maybe sometimes contact issues, they don't want to start sometimes, things like that. If you turn the lamp on and off frequently, it can shorten its life. The color quality of the light isn't as good as incandescent. That's another disadvantage. But otherwise, really their advantages outweigh their disadvantages.
Okay, guys. So if it seems like I am now in the middle of the night, it's because I am, because my computer shut down while I was recording the video. So anyway, that's it on lamps, okay? So it's those 4 types that you should know. The carbon arc, what was the second one? Incandescent, halogen, and fluorescent, okay? Those are the 4 basic types of lamps that are like old school. Now, there's also new technology like LEDs and lasers. And I don't have the same kind of content about those LED fixtures, but I do want you to get some understanding about them. So I am going to add an ed puzzle of the how it's made for LED fixtures for you guys too. There is a project, and that assignment I'm going to just make as a separate video that I will link with the assignment for you. So this lecture was your first component of today's class. Then there's a project where you're going to look up some information about different lamps online, do some research for me, and then I'll have you watch something about how they make source fours. So the LED source fours. Okay, so that's it for today. Thank you, thank you. Head into our next project video, and then finally you'll do the video about source fours. All right, guys. See ya.